right, Algebra 2. Yesterday we worked on direct variation. Today we're in Lesson 8.2 working on inverse and joint variation. Inverse variation, I use xy equals k. You can also divide by x, y equals k over x. Obviously x cannot equal 0, k cannot equal 0. Our essential question is, can you solve problems involving inverse and joint variation? So we're going to start with number 1. Number 1 says, if y varies inversely as q. Well, I don't have an x and a y, so I'm going to use y, q, I actually have a y, equals x, k. The first scenario says y equals 22 when q equals 6. So I'm going to plug that in. Y equals 22 when q equals 6. So I can solve for that constant of variation, and 22 times 6 is going to give me 132. And I'm going to go ahead and look at the second scenario. Find q when y equals 15. Well, remember we have yq equals k. And they're telling us to find q. We know y is 15. My constant of variation was 132. And 132 divided by 15 is going to give me 8.8. So my answer for number 1 is 8.8. Moving on to joint variation. Joint variation, we're really just going to read it in order. If z varies jointly as x, that means it's a direct variation, y equals kx, z equals kx, and the square of y. Notice the square is going to be something squared. The square root will actually be a root. Now, what if it said z varies jointly as x and inversely as y? Remember, inverse, like we saw at the top, we are going to divide. So let's go ahead and look and see if we can figure out an equation for this one. It tells us if r varies jointly as s and t and inversely as u. So the first thing we need to figure out is, can we write an equation here? Remember, we're going to go straight across. So we're going to have r equals k times s times t, and that inversely we're going to go ahead and put under the vinculum. So let's go ahead and do our first and second scenario. My first scenario says r is 18, s is 2, t is 3, and u is 4. So I'm going to plug all of this stuff in. All right, so let's start plugging numbers in. We know 18 is equal to, we do not know the k. We know s is 2 and t is 3, and all of that is going to be over u, which is 4. I could just reduce if I wanted to. And so I know that 18 is equal to 3 halves k. And to get rid of that 3 halves, I need to multiply by the reciprocal, which is 2 over 3. And it looks like k is equal to 12. So our second scenario says find s when r is 6, t is 2, and u is 4. Well, I know r is 6. I know k was 12. I'm looking for s. I have t as 2, and u is 4. And it looks like this 4 can go into this 12 3 times. And it looks like it says 6 equals 6s, so s is equal to 1. All right, the last one we're going to do, the time required to travel a given distance. The time required to travel a given distance is inversely. So I'm looking at time is inversely proportional to the speed. Well, I think that's right. Distance equals rate times time. So I'm going to call this time times speed equals k because it's inversely. And let's go ahead and look at the first scenario. If a trip can be made in 3.6 hours at a speed of 70, so we know the time is 3.6 at a speed of 70. Well, 70 times 3.6 is, oh, my calculator, 70 times 3.6 is 252. So my second scenario says, how long will it take to make the same trip at 90? So I know I have that ST equals K. I did find out that my K was 252, and they're asking us for the time, how long, and I know that 90 is going to be multiplied by T. When I divide each side by 90, T is equal to 2.8 hours. So the answer is 2.8 hours.